Hello, or pardon me, bonsoir, we're in Paris after all. My name is Brayden Thomas Edman. I'm the founder and technology strategist for Alexandrian. Now, I'm very excited to come here today and tell you about our company, but I truly believe that behind every great technology is a great story, and I'd like to tell you a story first. 2,000 years ago, in ancient Greece, there was a knot that no one could untie. They called this the Gordian knot, and they began to prophesize about whoever could untie it, what they would get, and rumor spread. Now, it's 2024 now, and I feel like we have a similar problem today. The big data problem community is our Gordian knot. The computational resources to solve these problems are insufficient. We have defense contractors looking to analyze battlefield analytics in real time. We have high-frequency trading firms who quite literally try to parameterize guava prices in Guatemala and correlate them with US Treasury bonds. What the industry has done is they've created a problem that is intractable to solve. Now, everybody here knows the potential of quantum computing to transform this space. But right now, quantum hardware is nowhere near term efficiency. And quantum computing companies are failing to package their materials into off-the-shelf products and licenses, which effectively destroys their ability to make money long term. Now, when I told you that story about about the Gordian knot, I left out a crucial detail. 2,000 years ago, when King Alexander of Macedon strove through Greece, he was confronted with this challenge. And you know what he did to untie the knot? He took out his sword and he cut it. Now, here at Alexandrian, I feel we have a more elegant solution to that. And here to tell you that solution is my co-founder and venture strategist, Mr. Tommy Pennington.
Let's go one more. Yeah. So the world desperately needs a solution to cut this Gordian knot, and at Alexandrian, we promise to do exactly that. What the world needs is a distributed high-performance computing platform built for quantum interoperability and able to bridge the gap between today's conventional and advanced computing technologies and the transformative quantum-driven approaches of the future. Yeah. And also, it's the perfect time to transform distributed high-performance computing. Many of the most exciting emerging technologies of today, from artificial intelligence and machine learning to computational chemistry to high-performance finance, all share one common thread. And that critical thread is they have intensive computational needs. This is creating a real-time market pressure for high-performance distributed computing solutions that are able to scale and embrace new technologies and hardwares as they come available to match the growing computational needs of these growing high-growth technologies. This has already created a $4.3 billion market opportunity this year, just looking at high-performance computing for the financial services sector. Scaling up and zooming out yields a $626 billion projected total market opportunity by 2026. At Alexandrian, we intend to fundamentally disrupt this space through our hardware-agnostic, software-based approach to optimize problem solving.
At Alexandrian, we are developing the software engine to realize a dynamic hardware infrastructure. What this means is we are incorporating advanced classical computers, supercomputers, and quantum computers into a single modular workload. What this means is that an incoming data problem can be broken down into fundamental workload units that can then be analyzed and routed to the appropriate hardware infrastructure. What this means is that we, as a quantum computing company, have the ability to offer something that's sort of foreign to the QC space right now: flexibility. What that means is that we can take a client's demands and we can tune our hardware to meet their ambitions, whether that be speed, cost, strategic efficiency. And as we understand, the quantum computing space expects to reach advantage on a case-by-case basis. And because of this, that means Alexandrian is perfectly positioned to grow with the quantum market, not compete against it.
Yeah. Critically, Alexandrian is fundamentally, first and foremost, a software company, which is why that we're choosing our hardware-agnostic approach, where we'll be able to integrate with any quantum solutions as they emerge, but also with existing supercomputing and advanced computing solutions. So really, it's not a one-size-fits-all. It's highly adaptable to the needs of the client. And we intend to accomplish this by building out our software stack. We believe that this has two primary goals. The first is the intelligent decomposition of big problems, and the second is an architecture-optimized routing process. We intend to build three fundamental engines. The first is our workload analysis engine, which, as Brayden discussed, breaks down a big data problem task into its fundamental subunits. We then have a dynamic optimization engine, which will assess each task individually for the best possible routing solution. Then our architecture translation engine will take those tasks and translate them from their native language into an algorithm best suited for the hardware that we intend to route them to. We also intend to have real-time monitoring and controls to predict problems before they emerge, and then to ensure that we can deliver the fastest, most efficient result every time on time. We believe our team is uniquely positioned to enter this frontier space from a disruptive, unconventional perspective. At Vanderbilt University, we founded the only undergraduate-led fusion research program in the United States, which we then successfully scaled to 60 team members and established major partnerships with fusion companies and national labs. That sort of got us onto the pipeline of computational chemistry, which in turn brought us to the quantum space. We intend to leverage our same institutional resources at Vanderbilt to achieve immediate results building out this quantum-focused software.
We are requesting a €510,000 pre-seed investment to develop an MVP. What this will mean is we will take the investment and we will develop a software engine and ML-driven engines. Thank you.
So first question for myself. So you are going to, let's say, dispatch computation in a computational workflow. How does that work? How do you integrate into the value chain between people who are doing the control electronics, people who are doing the applications? Who do you need to partner with, and who do you need to interface with?
So, you want me to answer that?
Yeah, I'll take this one.
So, what we're primarily trying to develop is a software license that we can sell, for instance, to a specific DoD contractor or a high-frequency trading firm. What that license will entail is the IP that allows that dynamic optimization and workload transfer. How we coordinate with the quantum computing industry is by analyzing quantum computing hardwares, for instance, supercomputing, trapped ion, photonic, and then incorporating those through partnerships into our workflow. Does that answer your question?
Yes,
Yeah.
but if you go one step further on the hardware, how do you interface with the hardware? I understand you would analyze the difficulty of the problem and decide which is the best suited platform or processor to treat it. Now, how does that come into play with control electronics monitoring the pulses in the computer?
Yeah, I think there's kind of two main approaches there. One is integrating with open source quantum SDKs as they come onto the market from companies like IBM, but also developing our own proprietary relationships with quantum hardware providers. So we kind of want to tackle it from both sides of the question.
Thank you. Any other question? Xavier? Question?
Well, I've been in the middleware business before, a long time ago, when the mobile technology, and it's a really tough space. You get squeezed between the hardware player who integrating their own software into their machines, and the large software guys, think IBM, Atos, and so on. So how are you going to survive that landscape?
Yeah, hopefully by functioning almost like a marketplace for quantum and high-performance computing solutions, we can add value on all steps of the value chain. So whether that's the customer who wants the optimized compute solution or the provider, hopefully just by acting as an intermediary, we're not stepping on anyone's toes, and it just kind of helps streamline the ecosystem.
What are the markets are you looking for? So clearly you're looking at high frequency trading, which is obviously an opportunity. But these guys, they might develop their own proprietary techniques, and they might even squeeze an even more nanosecond that you might be in the way of getting for them because of your engine. Is it, are there other type of industries you are looking beside these guys that would look for that kind of solution?
Yeah, I think outside of high-frequency trading, we're very excited about computational chemistry and some other more research-driven industries. I think there's also, down the road, once the quantum advantage has been achieved, probably some exciting opportunities more broadly within defense. But I think there's a lot of different verticals that could be interested in a very streamlined access to high-performance compute and quantum compute.